Thank you. All right, let's see how this works like that. Yeah, so that's me. I'm the general manager for the mioty Alliance since 2 years, actually, almost to the day. Before then, I've been in the IoT space for roughly 12, 13 years by now. Out of those 12, 13 years, it's been 10 years in the low power wide area network space. So I would say I'm a little bit of an LPWAN geek and IoT geek, maybe. I'll be talking about some of the things that we have been achieving and the values of LPWAN, but also, let's say, there are some dark clouds that we need to consider moving forward if we want to continue this actually quite immense growth that we've seen. But first, a few words about the mioty Alliance. So the mioty Alliance formed 5-6 years ago around the mioty technology to make sure that we actually push the mioty technology out into the world. We are active primarily in smart cities, utilities, and so on, but there are solutions now scaling out into critical infrastructure, industry, and other verticals. And it's a real pleasure for me to be the general manager for this because it's really an amazing technology. But let's just put that one on the table first here. So it is really an incredible technology, or a field of technologies, low power wide area networks. I don't know how many here are doing or have been doing LPWAN solutions, but I guess several of you. And I always get it's fun to explain to someone that really doesn't understand wireless what this is. Just by, okay, now this isn't the LPWAN device, but if you take a really small device with a small battery, and you tell them that, okay, you can take this device, measure the temperature, and you can transmit that message tens of kilometers, and that message will be received and picked up. And it's like they don't believe you. And then you say, well, the battery will last for 10 years at least, as well. So it is quite an eye-opener, and it's opened up a lot of interesting use cases. And I mean, if you walk around here, you'll see so many different solutions and lots of value that's been added thanks to LPWAN. And we're not done. There's so much more to be done. Primarily today, there's lots of monitoring, gathering data, and then you sort of do some smart things at the other end in various platforms and AI-driven solutions and so on. But you can add much more, and I'm sure this will continue because we've really opened up the opportunity here to utilize LPWAN in so many different use cases. Interestingly enough, the history is not so long. There are more companies, I'm sure, that we could put up there on this slide, but at least some kind of summary of some of the companies that have come and gone over the years. But in summary, I would say it's like 10, 15 years that it's been. 15 years there were some patents and developments on, but let's say 10 years ago there were real solutions coming out. But a lot of hard work. I was myself working for Sigfox many years and knocking on so many doors trying to convince both, well, all sorts of players in the field that this is really interesting. But this is the curve that actually, and this is the European evolution of LPWAN devices on the 868 band. And nothing happened. But then, like 5 years ago, things started moving. And companies and organizations really realized that this, it brings real value. We can monetize this. But if we then say this is really well done, we can take a beer and so on and cheers. The problem is that we're not alone here. There are a lot of other things also growing. There's lots more stuff using the ISM bands. So in Europe, it's 868, or one of the ISM bands. And this means that if we look at the spectrum, 7 years ago, was quite quiet, actually, because there wasn't many using it. Today, it's getting busy. And this is actually a big challenge. You can compare it to, if you go into, this is from Oktoberfest, maybe someone was there a couple of weeks ago. So if you go into one of those tents before the party starts and sit with your friends, you can sit fairly far away from each other and you can have a good conversation. A few hours later, when the crowd shuffles in and they've had some beer, I'm sorry, you will not be even able to communicate with your friend sitting next to you because there's so much noise. It's the same principle here. The more stuff you put in there, the more noise you will have. And this is a real threat to us. I was at the conference some months ago, and it was about AI and so on. So I took this opportunity to use some AI tools and ask, what are the main challenges for wireless communication? And ChatGPT and Copilot, they both spat out spectrum scarcity and spectrum management. Why is this? Well, very simple. The more stuff, the higher channel load, the more failed transmissions. It's like a road. You just have a limited space. If you put too many trucks on the road, you have a congestion. So what can you do about this? Well, you can use some intelligence in this, so you listen before you speak. You could decrease transmit energy, basically decreasing the footprint on the spectrum, making room for more. You could find other bands, meaning that you open up new roads, basically. The challenges here are, with LPWAN, for instance, so many of these technologies use quite a long time frame to transmit. So you listen, oh, it's silent, and then you start transmitting, but after a tenth of a second, there's something popping up. So the message will hit that noise. If you decrease the transmit power, well, then we lose the wide area, which is one of the key value propositions to LPWAN. Well, new frequencies, lots of work. New hardware, you need to have the discussions with regulators and things like that. So it's really a tough situation. And then we have something that actually will help and solve this situation. And to explain that, I'm using this picture. Some of you may have seen it before. This is an actual screen dump from the spectrum, showing what it looks like when you do a 10-byte transmission with these three technologies. So you have the LoRa message there, or two of them. You have Sigfox, and then mioty, these little dots. When you have a perfectly clean spectrum with no noise or anything, everything works nicely. You will transmit and you will receive and you will have 100% quality of service. But the simulation then is that this is a situation that we're seeing this in places already, and it's not going to be improving because there's more and more stuff using these roads, these bands. Mioty differs here in that sense that, so these little dots, they can actually get in between the noise. And the principle is this. So what we call the legacy LPWANs, you take the data, A, B, C, D, stuff it into one message, transmit. If there's interference, some of that data or the whole message will be lost. With mioty, we do it in a different way. So you take the same data, A, B, C, D, split it into a number of sub-packets. The standard modulation is 24. And there's some redundancy in these sub-packets. So you transmit them with slight time and frequency shift. What happens is some of these will be hitting noise. There will be interference, and they will be lost. But thanks to smart forward error correction, we can recompose the full message if we get 50% of those sub-packets through. So this is the real, I mean, this is the down to the mechanics and why mioty really is different. Benefits in real life. I'm going to use a few use cases here. So one of them is one of the members of the alliance called Swissphone. They have, I mean, they live off doing really important solutions to monitor life-saving equipment, to monitor lone workers and things like that, and they must rely on extremely robust technologies because they need to provide the security here. So this case here is about a rollout in Südtirol in the northern parts of Italy, quite a large area, where they're putting out these SOS emergency devices. And then they're using their own gateways with mioty. And this must work, because if someone presses this button, something must happen. If that message is lost, someone might lose their life. So they're betting on mioty here to make sure that they get through. A completely different type of use case is within smart metering. So this is a case in Stockholm, or just a municipality next to Stockholm. Stockholm is probably one of the most busy regions in all of the world as regards radio. It's really, you have so many different, I'm Swedish, by the way, so I know this. And it's a really busy radio environment. And DL Metering, one of the members also of the mioty Alliance, they have an installation there in a municipality just outside Stockholm, or at the edge of Stockholm. The requirement was from the customer to get 98% of the messages every single day, 24 hours a day, and year on and year on. And the only way they can do that was with mioty. Some of you may have noticed that mioty was signing an agreement with the IO-Link Association. IO-Link is, let's say, the framework for a lot of industries to have a common framework as regards signaling and so on for sensors and actuators in factories. So typically, 99% of everything they do is wired, because they need extremely low latency, robustness, and that they need to transmit quite a lot of data. Thing is, they have other things in those factories, like a tank with some liquids or whatever it might be in, or they want to monitor temperature, they need to monitor humidity and so on. Then they need to put sensors quite far away out into the outskirts of the factory environment. And if they have to pull a wire, it's going to be extremely costly. But now they've chosen mioty, as mioty is such a robust technology, to actually fix those corner cases. And this is going to be a big thing in the coming years, I'm sure. And again, factories, they really want to maximize uptime. That's the key thing here. It must not fail. Another aspect of this is how efficient are you actually on the spectrum? Meaning, I'm sending a message and I'm using this much space or this much space. If I only use a little amount of space, I leave a lot of room for others. So this is another really important thing that mioty brings to the table here. As the number of devices will continue to grow, the more devices that use mioty, the more we can actually put on the networks. And it's going to grow. I'm quite sure about this. And the forecasts, they picked up some reports here, and there's going to be the core use cases that we already see. As I said, lots of companies providing those solutions here, and you see a whole wall of different devices. This is going to scale. I think in Europe today, less than 50% of all smart water meters, are smart. Meaning, there's another 50%. The growth is like 100% the coming years for water meters only. Then AI, of course. AI is hungry for data, so there will be more and more stuff feeding AI, and also the other way around, where you will be opening up and using this to control. So we have a water leakage, I want to close the valve. Okay, so I get the response from the sensor, and then I send it out. Okay, close the valve. Again, more traffic on the band, because then you have first an uplink and then a downlink. So this means that we will need a lot more requirements for LPWAN. We could call it 2.0, we could call it, the list was actually a longer one, but something happened when I sent this to down here. But anyway, there's a long list of requirements that will all mean that we can reap more value out of LPWAN. But what I want to say here, without those two, it's going to be a difficult journey. Because as long as we're using the open bands, these bands, they're actually a physically limited resource. So we need to take care about this. With mioty, you will be future-proofed and make sure that your solutions will work not only now, but also 10 years, 20 years from now. Thank you. And before I leave, I would just want to make one little announcement here that one of our members in the Alliance, they will be speaking here in a few hours' time as well. Thank you.